Hello. Today I'm going to be talking about what pain is, and the answer is a great deal more complicated than you might think. So my name is Dr. Sarah Jarvis. I've been a GP for 28 years and a GP trainer for 24 of them. I'm also a fellow of the Royal College of GPs. So I spend a great deal of my time as a generalist dealing with pain. I'm hoping that what we're going to be talking about today will give you some of the answers to questions that I ask myself on a regular basis. So what are we going to be looking at in this module? Well, firstly, we'll be thinking about what pain is, what the processes are, taking us back to our anatomy and our physiology days. And then, how we measure pain. It sounds so simple, doesn't it? But actually, the physical, the psychological, the intensity, the impact on emotional arousal, they're all in there. What processes are involved in causing us pain? And what indeed is pain? We're going to be looking at definitions and causes of pain, but also looking at the various pathways involved, taking ourselves back to our anatomy and our physiology textbooks, because understanding pain and understanding how we can help pain is so closely linked to understanding what's going on. So what is pain? Well, pain has been around for a very long time, indeed, as long as humanity, and much, much longer. And of course, we've recognized it even then. Descartes, 1664. The animal spirits, the result of the flow of animal spirits from the ventricles of the brain to the body parts through the nerves. No, we're not quite there now. But the International Association for the Study of Pain has a definition that perhaps many of our patients would recognize, but interestingly, when we look at chronic pain, perhaps they wouldn't. So in general, pain is described as an unpleasant sensory and emotional experience associated with actual or potential tissue damage, or described in terms of such damage. But certainly when we come to chronic pain, we need to tease that out a little bit more. So you fall over, you stub your toe, you get a headache. What's happening? As with most pain models, we initially see cell damage occurring. So arachidonic acid is a key signaling molecule for pain transmission. When there has been a damage, tissue damage in this case, then arachidonic acid is cleaved from membrane phospholipids. Then the cyclooxygenase enzymes, remember them from our COX-2 inhibitors and so on, they come into play. So those COX enzymes catalyze the conversion of arachidonic acid into prostaglandins. Again, another way in which we've harnessed our knowledge of the underlying cellular processes, so the prostaglandin inhibitors. So conversion into prostaglandin in turn a key mediator of the pain response. Along with bradykinins, those prostaglandins sensitize nociceptors to transmit pain impulses to the brain. So let's start with the stimulus. Nociceptors are free nerve endings, receptors in tissues. Now these are activated by painful stimuli and sensitized to activation by prostaglandins, we've already just heard about those, and bradykinins. Remember those as well, because they'll be important later. Nociceptive signal conduction is mediated by voltage-gated sodium channels. Now there are two types of afferent nerve fibers and C fibers, with branching, terminal branches that permeate those end organs. We have the thinly myelinated, fast fibers, and of course the slow, unmyelinated C fibers. So these afferent fibers have cell bodies in the dorsal root ganglia, and they terminate in the dorsal horn of the spinal cord. A beta fibers are non-noxious, large sensory afferents from the skin. And each of these plays a part in the story, not only of acute but also of chronic pain, which has a pathophysiology all of its own. The gate control theory was revolutionary in its time. Yes, it has been disproved in the specifics, but this was a whole new ballgame. At the time, we had very recently discovered mechanisms of presynaptic controls of synaptic transmission from large non-noxious sensory afferents and the small sensory C-fiber afferents. So the theory was that the balance between those input could result in gating of incoming information. There was more to it than that, obviously. The convergence of various sized sensory inputs on spinal neurons that transmitted that sensory information to the forebrain. Descending controls, and they could influence biasing, which was established by that gate. It was great while it lasted. Subsequent clinical research, of course, proved the model to be incorrect in detail, but it is still valid today. It opened up a whole new world of research, and that has transformed our understanding of pain mechanisms. So the theory goes, could be opened or closed by physical, emotional, and behavioral factors. The gate theory may be wrong in the small print, but actually many of the concepts outlined here are still recognized to have a significant impact on our experience of pain, even if the details of the gate model itself have been found to be wanting. Yes, the gate is opened by bodily injury, but anxiety, depression, psychological factors. We know that people who are anxious or depressed experience pain more acutely. We also know that concentrating on the pain makes us more aware of it. How often have we tried to distract our children? Let's face it, that's fundamentally what Kissing It Better is all about. And of course, in reducing pain, yes, analgesia. Again, how do they work? Well, we'll go on to that later. But a positive mood, a positive outcome can have a fundamental impact on your perception of pain and on the effect that it has on your ability to function, on your level of disability. And of course, again, distraction from pain can ameliorate those sensations, whether it's kissing, rubbing, or indeed tapping, or whether it's psychological distraction. Look this way. So if we look at the pathways going on, we start with the parts of the brain involved, and we begin to get an idea of why pain is so subjective and so complex. And we can also begin to see why and where analgesics exert their control. So at the spinal cord level, the passage of pain information from the periphery to the central areas is controlled by a number of mechanisms, and these modulate the pain signals. So they include inhibitory control by higher centers, activity in collaterals like touch receptors, segmental spinal modulation by a variety of mechanisms which include endogenous opioid and cannabinoid systems, very topical these days, inhibitory amino acids such as GABA and nitric oxide, and many, many others. Now, once it reaches the brain, the main areas involved in processing incoming somatosensory information is the thalamus. But even here, there is so much more going on in that little bit. So functional brain imaging has been a huge advance. It has revolutionized our perception of pain and indeed our understanding of our patients' perception of pain. It's shed huge light on the pathways involved. So the somatosensory cortex, the anterior cingulate cortex, the insula, the prefrontal cortex, the thalamus and the cerebellum, all of them actively involved, activated by noxious stimuli. The sensory, the limbic and the associative regions have cortical and subcortical networks, and again, all of these can be activated by pain. Let's think again about that. The prefrontal cortex, surely that's the higher area. Thoughts, cognition. Yeah, absolutely. So much for recognizing we're in pain and where it comes from, but what about how we perceive it? How unpleasant is it? Is it burning? Is it stinging? Is it aching? What is the nature of pain? And again, brain imaging has furthered our knowledge considerably. So, the somatosensory cortices encode information about sensory features, the location, the duration of the pain. The limbic system, specifically the ACC and the insula, those bits are most important for encoding the emotional, the motivational aspects of pain. And then finally, when it comes to the link between pain and depression, anxiety, and indeed even loss of cognition, this is where the prefrontal cortex is king. So, how do we treat pain? Well, quite clearly, there are many different analgesics out there, and indeed they work at many different sites. Of course, non-steroidal anti-inflammatories work largely at the site of injury. Opioids, on the other hand, do not. There are no, as far as I'm aware, topical codeine products. However, we do know that opioids have a fundamental impact on the central nervous system if they're given systemically, and indeed, so do anxiolytics. We, of course, in recent years have moved a very long way away from giving tricyclic antidepressants to patients with depression. Indeed, they are virtually never used these days. SSRIs are used in the vast majority of cases, and yet we are extensively using tricyclics and indeed anti-epilepsy medications for the control of neuropathic pain. So all sorts of analgesics, all sorts of impacts, and again, functional body imaging and brain imaging has had a major impact on our understanding. Definitions and theories of pain continue to evolve, and functional brain imaging continues to further that progress. Pain can be a symptom of an underlying problem, but of course, particularly where chronic pain is concerned, pain can be a problem in its own right. At its most simple, peripheral nociceptor, spinal cord, brain. But at every stage, there are modulating factors. And measuring pain is not a simple task.